Welcome back to P1. Today we're moving on to Chapter 6 or Unit 6, Trigonometric Ratios. And we're going to start with a few from IGCSE. So the first one we're looking at is the cosine rule. Now, as we move into this trigonometric ratios unit, we cannot rely on only ever having right angle triangles. So we need to use things like the cosine rule and the sine rule to be able to solve problems with other triangles. Now, some of you may remember this already and you'll hopefully refresh your memory and get through quickly. Others may have forgotten this completely. But let's take a look. So here is a triangle, a non-right angle triangle. And if I label each vertex A, B and C, then opposite each vertex, so opposite A, I will put little a for that side. Opposite B is small b for that side. And opposite C will be little c, and that's for that side. So the capital letters at the vertices will stand for the angles at each vertex, and the small or lowercase letters, they stand for the length of those sides. Now the formula that we're going to be using is a squared equals b squared plus c squared minus 2bc cos a. And you'll notice that the a for small a and the large a, these will always be matching up. Okay, so if you want to find the size of A, you need the angle capital A. And obviously each of these letters can be switched. You can relabel a question in the exam and only use it in this form, or equally, I can go with B squared remembering it's cos B at the end, or C squared. Let's put A first. Like so. And all I'm doing is swapping my letters around. So this is the form I want it in if I want to find the length of a side. So this will help me find the length of a missing side. And if I want to find an angle, I need to rearrange this. So if I rearrange this and add 2bc cos A, I get 2bc cos A, b squared plus c squared, and I'm going to minus the a squared. So cos A is b squared plus c squared minus a squared over 2bc. And that then is the rearranged formula and the one that will enable me to find an angle. So when do I use the cosine rule? Now, just before we get into it, it's important to think about this, but the cosine rule is used when we're looking at these four pieces of information. So we're looking at 3 sides and 1 angle. So essentially, I can use the cosine rule if I know all 3 sides and I want to find an angle, or if I know 2 sides, 1 angle, and the missing side I want to find is opposite that angle. Okay, and that's quite important. So that's my option. So essentially 3 sides, 1 angle. If I got that scenario, in almost all cases I'll be using the cosine rule. But if I am finding a missing side, I do want that opposite the angle I have. Okay, here I've got a triangle ABC, and we want to find the value of x. So what I'd like to do here is first label my triangle to make it a little bit easier. So opposite C, small c, opposite A, small a, opposite B, small b. And b is what I want to find, that x. So b squared equals a squared plus c squared minus 2ac cos b. Now, if you're uncomfortable switching the letters around, like I've done in the equation here, relabel them. So cross them out and relabel them if that's what makes it easier for you, and so on. Okay? Anyway, let's get into this. So b squared is actually called x, so we're going to change that to x squared. A is 6.2 and c is 9.1. Put my squares in. 2 times 6.2 times 9.1 times cos 50. And then it's a matter of just putting this into my calculator. And we get 48.7. And this is obviously for x squared. So then square root in that, and I get 6.9798 and so on. Now my question was to one decimal place if you look at the triangle, so I'll do the same here. So we get 7.0 centimeters to one decimal place. Okay, let's have a look at this problem here. So we've got a question, find the size of the largest angle. Okay, so if I'm looking at the largest angle is always opposite the largest side. Okay, equally, the smallest angle would be opposite the smallest side. So the smallest side is 7, and if I wanted the smallest angle, it would be at x. Okay, but we want the largest angle, so we're looking at angle y. So cos y, and again, if you're unsure, change the letters into letters A, B and C that you're comfortable with. Okay, so this is now x squared plus z squared minus y squared all over 2xz. And just to get those, 11 is my y, 7 is my x, and 8 is my z as their opposite. So x is 7, so we get 7 squared plus 8 squared minus 11 squared over 2 times 7 times 8. And then obviously we'll do the inverse cos of that, and then my answer will be 94.1 degrees to one decimal place. Okay, I've got nothing to go by in the question in terms of rounding. So for an angle, it's often the whole number, one decimal place, or what is probably the most common, which is 3 significant figures. In this case, one decimal place and 3 significant figures is the same, but those are the most common ways of rounding an angle. Okay, while it's not necessary, I would always recommend sketching out these triangles. It doesn't have to be a perfect triangle, as you can see I've just done here. I'm just going to stick these on. AB is 4, BC is 6, AC is 9. Okay, and the smallest angle is going to be opposite 4, so it's this angle C. And that sketch just makes it a little bit easier for me to work out. So I want to find C, so it's cos C, and then that's going to be A squared plus B squared minus C squared over 2AB. Going back to my triangle, opposite B is small b, opposite A is small a, opposite C is small c. Now I can fill in my values. So we've got 6 squared plus 9 squared minus 4 squared over 2 times 6 times 9. That gives me, from my calculator, 101 over 108. And C is going to be the inverse cos of that. Obviously you don't need to write this down, you can just work it straight out in your calculator just by pressing shift cos and equals while that fraction is in your calculator. And we get 20.7 degrees. And I'm doing this to either one decimal place or 3 significant figures, as is common for angles. Again, quick sketch. We got AB 12, BC, and then AC. So A, B, C. This one's 17. AB is 12. BC is 10. I'm going to label them first this time. Remember, just opposite the angles. We want the largest angle, so that's opposite the largest side. So it's this angle, angle B. So cos B equals A squared plus C squared minus B squared over 2AC. Then filling in what I know, A is 10, C is 12, and B is 17. So it's over 2 times 10 times 12. And this time I'm just doing it all in one go, and I get 100.8 in my calculator. And this one I'm going to do to 3 significant figures. So 101 degrees. Again, sketch to help us visualize things. So A, B, C. AB is 5 minus x. BC is x plus 5. And AC is 7. Now, we want to find the value of x. We've also been given the angle BAC. So B to A to C means that this angle here is 60 degrees. So let's label the rest of the triangle. Opposite capital A is small a, opposite capital B is small b, and opposite capital C is small c. So since we're looking at capital A as an angle, we're going to go with A squared equals B squared plus C squared minus 2BC cos A. And substituting in everything I know, x plus 5 squared, B is 7 squared plus 5 minus x squared times 2 times 7 times x minus 5 times cos 60. Okay, now what I need to do is start sorting this out. So I'm just going to come down here where I've got a bit more room. So x plus 5 squared, so square the first, square the last, double the product. So that gives me x squared plus 10x plus 25. And then on the right side, we have 7 squared is 49 plus 25 minus 10x plus x squared. 2 times 7 here is 14. Cos 60 is a half, so the 2's would cancel, or half of 14 is 7. So we've got 7 times x is 7x, and 7 times negative 5 is negative 35. So immediately I could take away x squared from both sides, and I can also take 25 away from both sides. That will make my life a little bit easier straight away. That leaves me on the left side 10x, and then on the right I've got 49 take away 35, which is 14, and minus 10x plus 7x is minus 3x. So that will leave me with 13x when I add 3x equals 14. Therefore, x equals 14 over 13, or to one decimal place, this is 1.1. I'll put centimetres in there. Now, that's the question done for now, but you may have had a question that asked you for the size of the smallest side, which you can see in this case would be 5 minus x, so 5 minus 1.1, so it's going to give you 3.9 approximately. Okay. Final question for today, we've got 3 oil tankers A, B, C. They're in the same sea, so they're all on the same 2D kind of plane if you think about it. Ship B is 50 kilometers north of A, so if I think about A, directly north is going to be B, and that is at 50 kilometers. Ship C is 70 kilometers from A at a bearing of 0 to 0 degrees. So ship C, we're off here somewhere, C, this is 70, and this angle here is 20 degrees. Remember that a bearing is measured from north line, and it's measured in a clockwise direction. And then I can just join B and C here, just to kind of complete my triangle. Now for part A, we are trying to find the distance between B and C, so put a question mark here. And for part B, we're trying to find the bearing of C from B. Okay, now that would be, if I put, I'll do this actually in red so it stands out, I'll put a north line on B and measuring clockwise, so it's this angle that I want. Okay, but let's start with A, the distance. So I want to label my triangle. This will be small a, small b, small c, and I want to find small a. So a squared equals b squared plus c squared minus 2bc cos a. I'm filling in my values. That's 70 squared plus 50 squared minus 2 times 70 times 50 times cos 20. And that gives me 822. And don't forget to then take the square root, which will give me 28.7 kilometers. Okay, it's important to think about these if they make sense. It's quite easy for students to forget to take the square root there, especially under exam conditions. Okay, I've made a bit of room here and redrawn my triangle so that you can see. Now, I've got this 28.7 kilometers. I should always keep the full value though in my calculator. Best thing to do is to store it as a letter. So just hit store and then pick a letter like A, B, C or whatever. Okay, the store button on the newer ClassWiz calculators from Casio, you'll just see the STO above the number 7 button, just one button above it. And if you've got a slightly older Casio calculator, you need to press shift and that button. So it's the number 7, look at the button just above it and you'll see it. Okay, so this is the angle I want to find. The bearing, so it's measured clockwise from B. So the question is asking the bearing of C from B, means I'm starting at B and I'm finding the angle that measures clockwise from north at that point B. Now obviously I can't find that straight away, but what I can do is I can find this inside angle B here. Okay, now this particular one, there is another way of working it out when we look at the next video, but for now we'll stick with the cosine rule. So we're looking at cos of B, and I'm just going to relabel my triangle quickly for my A, B and C. So cos of B is A squared plus C squared minus B squared over 2AB. So A squared there is this 28.7 squared. Remember to use the full value. C squared is 50 and B is 70 squared there. So 2 times 28.7 times 50. And I do apologize, it's not a B on the bottom, it should be a C there. Now, putting this into my calculator and finding this angle B, and that gives me 123.4 degrees. So it actually means that my diagram is not the best. The B would have actually been a bit further down, and the B to C would have looked a bit more like this. But it's not important. Now, to find my bearing, it's on a straight line, so it's 180 minus this. So 180 minus my 123.4, and that gives me 56.6 degrees. So the bearing of C from B is 0.57 to the nearest degree. Okay, bearings obviously are usually in 3 numbers and to a whole degree.